So in this problem, we are given 4 lines and an equation. And these lines intersect with each other such that they form a rectangle, and this rectangle is circumscribed within a circle. Now we need to find out the equation of that particular circle. Let's try to understand this problem graphically first. So here we have a rectangle inscribed within a circle. We need to determine the equation of a circle. Here, this particular circle, it's given here that this rectangle is formed by these 4 lines. So let me say that I consider the vertices of the rectangle to be A, B, C, D, such that AB is represented by the line, let's say x minus 3y equals to 4. BC is representing the line 3x plus y equals to 22. Well, you can plot this line on a graph paper to get the accurate diagram of the rectangle, but there's an easier way to represent the sides of the rectangle with the following equation. Because if we look at equation number 1 and equation number 3, we have both of these two equations are going to have the same slope. Similarly, equation 2 and equation 4, which is 3x plus y equals to 22 and 3x plus y equals to 62, both of them are going to have the same slope. So that means they are going to be parallel to each other. So this is how we can represent the sides of the rectangle with the following equation of light without taking the help of any graphical calculator. And CD is equals to x minus 3y equals to 14, and DA is representing the line 3x plus y equals to 62. Fine. So how do we find out the equation of this particular circle? Then we can here use the diameter form of a circle. Let's first specify the diameter form of a circle. So let's say we have a diameter, and the endpoints of the diameter are A, x1, y1, and B, x2, y2. Then the diameter form of a circle is given by this particular equation, x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals to 0. So our goal will be to find out the endpoints of all the 4 vertices of the rectangle, and once we have the 4 vertices, then we can join A and C, and this is going to become the diagonal. The diagonal of the rectangle is also going to become the diameter of the circle, and using the endpoints we can find out the equation of our circle. So let's try to find out the point A and point C. To find out point A, what we'll have to do to find point A, we'll start with this. We'll have to solve the equation x minus 3y equals to 4 and the equation 3x plus y equals to 62. So let us first name this equation as 1, 2, 3, 4. So here in our case we have to take equation 1 and equation 4. So here we have equation 1, and equation number 4 is 3x plus y equals to 62. Let this be equation number 4. So what we'll do, we'll take equation number 1 and keep it as it is. So we have x minus 3y equals to 4. Now we're going to take equation number 4, but we're going to multiply throughout with 3. So we have 9x plus 3y equals to 186. Now we have 9x plus x. What we're going to do is we're going to add the two equations. We get 10x, 3y and negative 3y cancels out. 186 plus 4 is 190. So x comes out to be equals to 90. Now we have the value of x. We can substitute either in equation 1 or equation 2 to obtain the value of y. So let's go with equation number 1. So here we have 19 minus 3y equals to 4. So 3y will be equals to 15. Then y will be equals to 5. So that means the coordinate of point A, that's going to be 19, 5. So let's note this down. Coordinate of point A will be 19, 5. Now we need to find out the coordinate of point C. To find out the coordinate of point C, we need the equation 3x plus y equals 22. So that's equation number 2. And we need the other equation, x minus 3y. This is the equation of the line which is representing the side DC. This is equation number 3. Fine, we'll go the same way. So we'll take equation number 2 and multiply it throughout with 3. So we get 9x plus 3y equals to 66, and we keep equation number 3 as it is. It's going to be x minus 3y equals to 14. Fine, so we get 10x equals to 80. So x value comes out to be 8 units. Substituting this back into equation number 2, but we're going to get 3 times 8 plus y equals to 22. So where y equals to 22 minus 24, so y comes out to be negative 2. So that means coordinate of point C is 8 comma negative 2. So I've obtained the 2 points. A is 19 comma 5. So A is 19 comma 5 and C is 8 comma negative 2. What we can do, these are the endpoints of the diagonal. So let's write it down. Are the endpoints of the diagonal AC of the rectangle ABCD. Now we know that the diagonal of a rectangle inscribed within a circle is going to pass through the center, meaning AC is going to be the diameter of the circle. So we have the diameter of the circle whose endpoints are known. So that means the equation of the circle will be now x minus x1 multiplied to x minus x2 plus y minus y1 times y minus y2 equals to 0. So this is going to be the required equation of a circle. Similarly, you can obtain the other coordinate B and coordinate D, and using the same procedure, you can also find out the equation of a circle. Anyways, we know that the diagonal BD is also going to intersect the diagonal AC at the center. So that means the circle equation of the circle that we obtain by taking the help of the endpoints of the diameter BD, it's going to be exactly the same circle.